Namaskar, my dear friends. So we were continuing with the circuit design of PIC18F47Q10. Okay. So we had seen the power supply and different peripherals. Let's say programming connector or how to connect this reset switch or how to connect this open drain pin. And we had seen a small pot connection as well, potentiometer connection. Now we had to continue with our user push button and user dip switches. Okay. So what I have done is user push button is connected through this 100 kilo ohm resistance and a 5 volt supply. Okay. So VDD was there which was 5 volt, and this is 0 ohm resistance and this is 5 volt. So this is how I have converted this to 5 volt net name. Okay. So net name change can be done through a 0 ohm resistance that we can do. So we have the 5 volt available here, and this user PB0 is going to this, and this is going through the RB0. So RB0 will be taking as user push button 0 input. So whenever this push button will be pressed, so whenever this will be pressed, what will happen? This particular 5 volt will go to ground. So this user PB0 will be seen at RB0 as a ground, that is 0. So the logic at RB0, which is here. So in the beginning it is high. Okay. Now as soon as the user push button will be pressed, it will be low. All right. So as soon as it becomes low, you will be understanding that the push button has been pressed. All right. So similar to that, other push button is also there. User PB1, which is going to RB1. Got it. Next, another thing is, I have already explained you this user push button and dip switches in our previous videos as well. So this is very easy. Sometimes what happens is, like you have to set some of the pins, let's say user dip switch 0, 1, 2, 3 to some values, let's say 0, 0, 0, 0 or 0, 0, 1, 0, something like that. Any settings you want to do. So I have sent these to four of the, our port pins RD0 to RD3. Got it? So let's say we have to set all of them as 0, 0. What will happen? The dip switches is open left, like this side, and close this side. So I will keep all the slide switches this side. Understood? So all of them will be at 0. Now let us say I have to put this configuration. So in that case, what I will do? User dip switch 2 will be set at 1. So this switch will be set this side. Got it? So this is how I will be able to set any of the configuration. If you want to use, like a 2-pin user dip switch, or like a 4 position or 8 position, any position you can take up. And this is one of the dip switch which is directly taken from Worth Electronics. Okay. So Worth Electronics is one of the best company for dip switches, connectors and all those things. Even CUI devices is one of the good company for dip switches with a lower cost. Okay. And this push button is also taken from C and K, and as well as Worth Electronics. So both of them, the part numbers are already there in the previous videos. As well, if you need the exact part numbers for this push button and dip switches, you can put your comments in the comment box, and I shall be able to answer you out. One very versatile and very popular peripherals is LEDs. So we will talk about LEDs, how we can connect LEDs to the uh, port pins of microcontroller. So what I have done is I have taken user LED 0 and user LED 1. Okay. So in these two user LEDs, what I have done is I have connected 5 volt connect here voltage through a 1 kilo ohm resistance and the LEDs. Okay. So LEDs again taken from Worth Electronics, and it is going to LED 0. So LED 0 is going to get connected to RD4 port pin. Got it? And whenever RD4 will go, let's say I have kept it high. Okay. And whenever it will go low, then this LED will glow. Okay. And whenever it will be high, then this will not glow. Got it? So this is how the connection is. So basically the microcontroller port pin will be acting as a sink. Okay. So this is acting as a sink. Got it? Similar to that, D4, that is LED D4 will be also you having the same functionality. Another way to connect LEDs is this one. Okay. So what I have done is I have connected LED 2 and LED 3, user LED 2, user LED 3 in the microcontroller pin directly. So that is going to 2 and 3, which is RD6 and RD7. Got it? Now whenever RD6 will go high, this LED will start glowing. So here my microcontroller pin is acting as a source. Understood? So this is another method to make sure this is happening. One more thing, while connecting the resistance values, what you have to understand is what is the drop of this particular LED. So let's say my particular LED is having 1.3 volt drop, okay, or even 1.7 volt drops are there sometimes, but let's say generally 1.2 to 1.3 volt is there. Now this voltage is 5 volts. So what is the voltage available at this resistance? So 5 minus 1.3 divided by 1 kilo ohm, okay. So this much milliampere will come, okay. So you have to understand what is coming. It is 5 minus 1.3, that is 3.7 milliamps. So 3.7 milliamps current is flowing in this, okay. If you want to increase the current, you can go ahead with let's say 500 ohm. So in 500 ohm it will become 7.4 milliamperes. So you have to make sure the resistance values must not be lower, so that it is the current drawn is more than 20 milliamps, okay, because the microcontroller cannot give you more than 20 milliampere current. So I'll suggest you to utilize 1 kilo ohm, or even around this value only, like let's say 680 ohm or something like that. But if you are working with a 3.3 volt application, then you can go ahead with little lower values, okay, let's say 330 ohm or 470 ohm or something like that. So I have given a very brief idea about how to connect different LEDs for different voltage level in my one of the post, so that you can see. Anyway, what I have done is another connection. Sometimes what happens, very powerful LEDs has to be connected in the indicators. So in that case, what I'm going to do is I'm going to use MOSFET to drive this particular LEDs. So in that case, what happens, my microcontroller port pin will go high, and this will switch on this particular in MOSFET. So this path will get completed and this LED will start glowing. And as soon as you make it low, then it will go off, okay. So in that case, very high current, let's say you need 30 milliamps or 40 milliamps current. So in that case, accordingly you will be able to adjust your uh, resistance values, and at the same time you won't be able to destroy your port pins, okay. So you cannot damage your port pins, because port pin is not driving any current, because it is at the gate of the MOSFET, okay. So gate, drain and source. And this BSS 138 is very versatile, popular, and very easily available MOSFET from many many manufacturers. Let's say NXPRIA is there, okay, or even onsemi is there. Other manufacturers are also there as well. So similar to that, LED user LED 5, user LED 4 also I have connected, and it is going to RE1, RE0 and RE1. All right. Good. So we are clear with push buttons and LEDs. Let us now connect to some other peripherals. So we'll be talking about temperature sensors. Okay. So this is having a capability of plus minus 1 degree centigrade resolution. So 1 degree centigrade resolution. And this has the capability of SM bus interface or I2C interface. So what I have done is I have put I2C interface. So I2C SDA and I2C SCL line will be connected to the microcontroller pin, which I'll just indicate for you now, and then we'll see later. So this you can see SCL and SDA. So you can rename this I2C SDA and I2C SCL, so that you can connect this particular line to this particular pins, okay. So this is how it will get connected, and I have kept here pull up pins, so there is no need to pull up near the microcontroller. Here only I have put it, so that respective peripherals is making sure that I2C is taken care, okay. Now what is happening here in this particular temperature sensor is, through this I2C there is a number that is set in the temperature sensor, which is, let's say I am setting it to 50 degrees centigrade. So whenever the temperature sensed by this particular temperature sensor is more than 50 degrees centigrade, you give me an alarm, okay. So this alarm is alarm bar, that is low. So whenever this particular temperature sensor will sense a temperature more than this, this particular alarm pin will go low, and this alarm pin will be connected to one of the pin of microcontroller. So that will see low and it will trigger a alarm. All right. So whenever you are seeing that temperature is more than the like set value, microcontroller will receive alarm as low signal, and this is how it will decide that the environment is more than the temperature that is decided. Okay. Similar to that, address pin is there. So address pin, I have pulled it high. You can pull it low, or you can connect it to one of the microcontroller IO pin, which will set it high or low based on your like understanding. So either since it is only one device, so you can permanently keep it high or keep it permanently low. That doesn't matter. Both of them will be same. If you want to use two devices, same two devices, so definitely you have to put one of them as high and one of them as low. Okay. So this will be grounded and one of them will be high. So this is how you will be able to distinguish between these two particular devices. So this is how we try to connect a temperature sensor with I2C interface capabilities through the microcontroller. Some of the very popular analog temperature sensors are also there. So I'm going to take one of the temperature sensor from microchip technology. So this is the package having SOT23 package. Okay, so this is just having 3 pins, VDD, that is power supply pin. You can give it to 3.3 volt as well. So I have already given you one 5 volt to 3.3 volt regulator. So that 3.3 volt input you can take up. If this particular temperature sensor allows 5 volt input, then you can connect to 5 volt as well, so that you don't have to utilize your 3.3 volt regulator. Okay. Next, the output pin will be connected directly to the ADC pin. So what I will do is, this temperature temp out 1 will be connected to one of the ADC pin of the MCU directly. So you will be able to get your temperature value. So how this temperature sensor is working, let me tell you directly. Is let's say you got a temperature of 20 degrees centigrade. So at that 20 degrees centigrade, you will be able to see a voltage 0.7 volt. So if you are seeing the V out as 0.7 volt, you will be able to decide the temperature is 20 degrees centigrade. Got it? If you are seeing 40 degrees centigrade, it means you will be able to get 0.9 volt. So 0.9 volt, you will be able to see 40 degrees centigrade. So as you can see, for each degree rise in temperature, okay, there is a voltage rise of 0.1 this is 0.01 volt or 10 millivolt per degree centigrade. Got it? Let me tell you, like 20 to 40 is what is the range? 20 degree centigrade change. And what is the temperature? What is the voltage range difference? That is 0.2 volt. So you can see 0.2 volt, that is 200 millivolt. So 200 millivolt by 20 degree centigrade, that is coming up 10 millivolt per degree centigrade. So this much millivolt per degree centigrade. All right. So this is very, very useful, temperature sensor, analog temperature sensor, and very sturdy. And this is just a SOT23 package. And many people are using this for their temperature sensor application. If you want to replace this particular temperature sensor with little lower cost temperature sensor, so you can go ahead with a Texas Instrument. So Texas Instrument has same IC SOT23 package, but this is TMP235A. Okay. So TMP235A is having same functionality as microchip temperature sensor, which is TC1047A. Okay. And as you can see from this particular temperature sensor, we have a table of the temperature conversions. So let me just give you a glance of temperature conversions. Let's say at minus 40 degrees centigrade, you will be seeing the output at 100 millivolt. So this is my ideal values and this is my piecewise linear value. Okay. If you are going to see 20 degrees centigrade, then you will be able to see 700 millivolt, which was there in microchip technology temperature sensor as well. And here also piecewise is same. If you are going to see 40 degrees centigrade, then 900 millivolt or 0.9 volt. This is also 0.9 volt. So based on this table, you will be able to decide what is the voltage value that is read at the ADC pin, and correspondingly you will be able to see what is the temperature. Got it? So if you are seeing 1.05 volt, or that is 1050 millivolt, you will be able to decide the temperature is 55 degrees centigrade. Got it? Now sometimes what happens is, what is happening these days is, there is very long lead time for SOT23 package. Okay, so Texas Instrument or other like manufacturer has come up with SC70 package, which is like 6-pin package. So that also you can replace. So this is my this is my 5-pin package, SC70 dash 5, you can write out. So this 5-pin package is very like easily available with very high volume. Okay, so if you want to utilize this particular temperature sensor in your mass production for high volume applications, then you can utilize this particular temperature sensor as well. But this has exactly same functionality as just now I told you about TMP235. Okay, which is SOT23 package. So this is also TMP235, but the package is changed, which is DCKR. Okay, so DCKR is actually SC70 package. Okay, and it has also 5-pin, but you can see pin number 1 and pin number 5 are not connected pin. It means they are not used. So only 3 pin are effective, which is one is ground, one is your power supply pin, and one is your V out pin, which is directly connected to your one resistor I have put and one capacitor, which is acting as a filter, and then it is going to a ADC pin. Okay, so ADC pin I will decide based on the like availability of the pin in the microcontroller, and you can name that particular IO as TMP underscore out 3. Got it? Now I want to tell you one more thing. Before giving it, a very good designer, what they are doing is, before giving it directly to the microcontroller pin, it is always suggested to put some buffer or some amplification if there is a need. Okay, later on. So what I have done is, this output pin I have put temp 0. Okay, so temp O is there here, so temp O is getting connected directly here. Okay, and then this one is going to a buffer. So this is my buffer. This is LM358 IC, that is amplifier, and this is going to temp out 4, which is one of the ADC pin of microcontroller. So this is a very good like technique to convert it, I mean pass it through a buffer and then send it to your ADC pin for better like ADC functionalities. Okay, or otherwise you can send a temp out 3 also directly from here to here, and then buffer it and then send it to your ADC pin. So after filtering and then send it to ADC pin, so that is much better. Okay, good. So hope you have understood how you can connect a particular like output to the ADC pin, either through the filter or through the filter and buffer, or directly through the buffer. So whichever suits the application best. And in this particular aspect, what I have done is I have utilized both of the functionalities, so that because we are using a general idea of how to connect a particular temperature sensor to the ADC pin of a microcontroller. Okay. Good. Let us move to the next application which I am going to utilize is EEPROM. So EEPROM is like mostly used through I2C communication. So I have taken one I2C interface based EEPROM from Microchip Technology, which is 8024C04C. Okay. So this is a 4 kilobit EEPROM, and it has two like address lines, which is A1 and A2, and this is my ground pin VSS, and this is my SDA line, that is I2C SD data line, and SCL line, that is I2C clock line. Okay, and this is write protection. So write protection, if it is high then it will not allow you to write, and if it is low then it will allow you to write. So by default I have kept it low so that I don't want to waste a microcontroller pin. Got it? So if you see this WP line, if you want to connect through like one of the MCU pin, okay, then that will go, when that will be kept high always. Okay, so that it will not allow you to write. Now whenever you want to write something, then you can make it low and you will allow, it will be allowed to write. Got it? And this is my VCC pin, which is power supply pin, and it is connected through a 4.7 microfarad bulk capacitor and zero point 0.1 microfarad like a filter capacitor. Okay, now like this EEPROM, you can connect how many, like we have A1 and A2 two address lines, so total A2 A1 is there, so 00011011. So total 4 combinations you can keep of these two address lines by connecting it either to like pull up or either to pull down. Got it? So like this you can connect, and you can connect and set the like address lines as 00011011, and based on that you will be able to utilize four numbers of EEPROM together. Got it? Good. So you have understood the EEPROM interface as well, and this I2C SDA and I2C SCA line will be connected to the microcontroller I2C lines. Now, one very important application which is generally used externally in low-end microcontrollers, low pin count or low-end microcontrollers which do not allow RTC application in built applications. So in that, what happens is RTC application can be utilized from external. So this is a RTC application IC which is DS1307 plus, which is taken from Maxim Integrated. So Maxim Integrated is actually a part of analog devices. Analog devices and Analog Devices is one of the best company, and they have very good capabilities of IC manufacturing in different sectors. Okay, and Maxim Integrated as well as Linear Technology both are very good companies, and that's how they have been acquired by Analog Devices. So this RTC application IC is also having I2C application. Okay, so this I2C application interface can be connected directly like this, and here it requires one oscillator which will be low frequency oscillator, that is 32.768 kilohertz, and this particular part number is already given in our previous videos as well. And if you need a particular part number for your selection and particular design of this C77 and C78 values based on your selected part number, then you can put your comments in the comment box and we shall be able to answer you all. But the way to connect is you can connect OSC X1 underscore OSC here and X2 underscore OSC here, so that you will fulfill your oscillator requirement to this particular RTC IC. And then VBAT3 you can connect a 3-volt point cell, okay, which will be supplying in the absence of power supply. This is 5-volt power supply. Okay, so whenever if it is not available, your device is not switched on, then at that time this coin cell will be supplying the voltage to this particular IC, or otherwise 5 volt is always there to supply the power. Got it? So this is how you fulfill your RTC requirement. Good. Next, we shall go ahead with a very robust application of temperature sensor. I will tell you one more, which was very, very, useful. So this is again 1 degree, temperature sensor, which is having 10 millivolt per degree centigrade range. And this is TO92 package, TO92 package, and this is basically used in your, thermometer applications or automotive applications or so many applications. And this is very, very versatile, robust. Okay. So instead of using your TMP, just now I told you this TMP series, that is SOT23 package, generally you want to go ahead with TO92 package. Okay, and this is connected directly to 5-volt supply, and one is ground, and output is directly connected to RE2, which is going to be a ADC pin. Okay, ADC pin. Good. We can always adjust the port pins based on our convenience and the availability of port pins in our microcontroller. So at last I will be giving you a complete circuit design of only required interfaces, and complete system how you can make a particular board and you will be able to utilize in your general applications. Okay. Good. Now, sometimes what happens is we need, beep alarms or something like that. Whenever there is something some temperature rise, or let's say some problem is there in your, circuit or software, and you want to put a alarm beep. Okay, so beep sound. So for that, I have given one, magnetic buzzer. So this is my magnetic buzzer taken as CST-951AP from CUI devices, and this is connected through one diode which is recommended. Okay. I have given a provision of resistor as well, so that it can be some other kind of buzzers can be also used which require resistor across them. Okay. Now how this is being operated is, I have a pin which is RE0, which is capable of generating PWM signal. Okay. So this PWM signal, what you can do is you can generate a 2.7 kilohertz PWM signal and send it to the base of this particular like transistor, and this will be giving you the beep sound. Now what you can do is, if you want to like increase or decrease the sound quality or something like that, you can increase the duty cycle of the PWM signal. Now one more thing, if you keep a lesser like a PWM frequency or higher PWM frequency, you might not be able to hear the sound, so you have to adjust the PWM frequency just around 2.7 kilohertz, and you will be starting to listen to the beep sound very easily. Got it? So this is the very good application and very easy application for your microcontroller interface with a like a buzzer. Okay, now what we are going to take one more application is IR sensor interface. So IR sensor interface is basically used in your like remote control applications. So in this remote control application, whenever this particular like sees any IR sensor, it will give you an output, and this output is going to a pin RB0, and this RB0 will be able to take some actions based on that IR sensor detection. Got it? This is very easy. We have the VCC pin, power supply pin, which is get connected to 10 microfarad capacitor and 0.1 microfarad filter capacitor with your 5 volt supply. And this 100 ohm is actually recommended from the data sheet of the manufacturer. So that's the reason it has been given here. And this particular output is taken to the like your I mean IO port, which will be like seeing the high or low based on the IR sensor detection. Got it? So this is very easy and like a very versatile application that is being used these days. Sometimes what happens is you need some external interface also. So I have given a 6-pin connector which is going to external interface, where what is there is we have supplied the VDD power supply so that that particular board can be powered up. At the same time, ground is also taken back so that this 2-pin is helping that particular board to power up the system. Another thing is we have a enable signal that we are sending it, okay, that we are sending it from our microcontroller. So this is acting as a output pin from the microcontroller and going to the like next board interface. Got it? Next is suppose that board has been switched on or not, something like that, then that signal on off has been taken to the microcontroller pin again. So this is acting as a input to the microcontroller. Okay, so this is how you decide how you can be keeping output pin and how you can be taking input pin. Got it? Now I have taken two lines which is like ADC0 and ADC3. So ADC0 is one of the ADC that has to be like measured from the board. So this board requires ADC0 measurement and ADC3 measurement, which is some voltage level that has to be measured here. So what I have done is I have taken here ADC0, and this is going through a buffer, and that is going to the RA1. So RA1 is one of the port pin which is capable of having ADC measurement. Similar to that, RA2 is taken for other one, ADC3, which is not going through the buffer. If you want, you can put buffer here as well, okay, and send it so that it doesn't like give you any trouble. But one of the ways, let's say it doesn't require any buffer, it has already been buffered in the like respective board, and you just can filter out and send it to the ADC of the microcontroller pin. Got it? One more option I have given in like this particular circuit design is, this is my 5 volt supply which is going to go through the voltage division of 30 kilo ohm and 20 kilo ohm. So this voltage is basically 2 volt. So this 2 voltage will be like going through the buffer circuit and going to the RS0 of the ADC pin of microcontroller. So based on this 2 volt reading, you will be able to understand your power supply is stable or not. So to understand, to detect, or to like decide the power supply which is available to the microcontroller board is stable or not stable based on this particular arrangement. Okay, and here you will definitely need the like a buffer because because this is what do you say, voltage divided by 30 kilo ohm, 20 kilo ohm. So the current rating is very small here. You can see 5 volt by 50 kilo ohm. So that is going to be 0.1 milliampere. Okay. So 0.1 milliamp may be very less for this particular ADC pin to charge the ADC very quickly. Okay, so for that reason you need a buffer, and this is how you will be able to see the voltage levels. Good. Next is one more, which is going to be LCD interface. So I have taken RC0. Okay, RC0, RC1, RC2 and RD0 to RD7. I already told you that this particular microcontroller has the capability of 8-bit data communication through RD0 to RD7 pins. So this RD0 to RD7 pin has been used for the LCD data communication, that is DB0 to DB7. Got it? Now we require some of the signals, like let's say RS pin, RW pin and EN pin. Okay, so those three pins has been used as three different pins of the microcontroller. And at the same time this VDD pin is used for the anode voltage, and this cathode is controlled through one of the IO pin of the microcontroller. So this RE1 is going to switch on or switch off this particular transistor, which will be grounding it. So once it is switched on, what will happen? This particular transistor will start working, and this cathode will get grounded. Okay, and whenever you want to keep low, then this will be open and it won't be grounded, it will be floating. One more option that you can utilize for this cathode pin is you can utilize one 0 ohm resistor. Okay, and keep it not used right now and keep it grounded. Okay, so instead of using your one of the port to do this particular job, okay, so in that case you can avoid all these particular circuits and you can directly mount this to ground permanently. All right, so I'll suggest not to go ahead with this way. You always go ahead with this transistor based control, so that you based on your need you can control this particular LCD. Now we have one contrast pin, which is VO pin. So VO pin is connected to one of the port, that is potentiometer. So this port is being controlled by VDD supply voltage, and based on the contrast need, you can set this particular port value at required resistance levels. Okay, so whenever your eyes feel like, okay, this is the good contrast, it is giving good picture of the characters, then you can keep it permanent, that value. And this is the VDD pin, which is power supply pin. So power supply pin is given with a bulk capacitor of 10 microfarad and 0.1 microfarad capacitors. And this capacitors can be connected to VDD pin, and VSS is your ground, which is connected to the ground pin. So this is an LCD of 16 cross 2 characters. Okay, and it is very useful LCD, very easy to communicate and very easy to interface with a microcontroller. So this is how we have seen almost all the interfaces for this particular microcontroller that we have talked about, and I guess we are now ready to design this complete microcontroller circuit. And if you have any doubt or any questions regarding this particular microcontroller still, like how to select the particular pin for a different functionalities, let's say UART, I2C, SPI, so those things you can put down your comments in the comment box, and I shall be able to answer you out very quickly. In our next session for this particular microcontroller, what we will do is we'll try to understand some of the basic application of UART, like RX and TX pins, as well as SPI interface, like slave select pins, or let me just tell you, SPI connections will require your MOSI, MISO and slave select or SS pin. Okay, or chip select pin, correct? So these all things we will try to understand in our next session. Similar to that, UART connection also we'll try to see, which I was telling you about, how to connect UART to USB, and UART to RS232 and all these things. So that we'll try to understand in our next session. Hope you have understood almost all the basic requirements or basic understanding of this particular uh, powerful microcontroller, which is PIC18F47Q10. And I'll tell you one more thing, I have given you exact design with 40 pin PDF package, but you can utilize the same thing exactly with your TQFP package as well as QFN package both. Okay, so even QFN package having 40 pin connector, 40 pin availability, and TQFP is available in 44 pin package. So both of them can be utilized. So if you want to have better thermal capabilities or like heat dissipation capacity, you can always go ahead with your QFN package. All right, guys. Thank you.